that's actually quite important, right? Because if you look at it, Transport for London did a study that was presented in, I think, the House of Lords, where, and they did this like 10 years ago, I think, where they showed that every mile per hour that road speed declines costs them 250 million a year. And road speeds have dropped more than 10 miles per hour in the last decade. So that's 2.5 billion. Right? So yes, that could be a money-making enterprise if we tackle congestion. Now, if you start that, then you can invest loads of things, right? More buses, more frequent buses, nighttime buses. Oh, and by the way, we could make them electric as well, because that's the cheapest way to run a system anyway.
Welcome to this week's episode of Akoni Tech Talks. We are joined by Steven today. It's a pleasure to have you here, Steven.
Well, thanks for having me.
And in true Akoni Tech Talk style, we are going back to the beginning to find out a bit more about your career and background. So, Steven, I'd love to start with what first drew you to the energy sector in particular, especially after coming from a trading background.
Well, actually, if you go really back, I started my education in energy, right? So I studied as an electrical mechanical engineer. So that usually has to do with motors or power plants, turbines, right? So anything that revolves and uses electricity or makes it. So, and then as I went from engineering degree into my business degree, I ended up working part-time with a company called AES. They're a large independent power producer in the US, who was actually one of the first to put grid-scale batteries onto the network in the US. This is early 2008, so it was very niche back then. And what I always liked about it is that, well, you've got technical challenges, but also the economical or the commercial isn't very far behind. It's all about how can you use technology to solve a commercial problem or vice versa, and about generating many options and then optimizing across that option. So flexibility and all that stuff is really at the core of the energy market. And I thought that was quite interesting. And then secondly, if you go back to 2008, everybody talked about the energy trilemma, right? Reliability, affordability, and security. And I found recently we're still talking about that, right? And the focus has perhaps shifted from one of the three pillars to some of the others. But I think that's what's so exciting about the energy transition, is you're really at this interesting time, which is really a perfect storm of lots of different factors.
Mm-hmm. And you talked about that interest in, going as far back to, your initial introduction to energy, but what kind of led you to co-found Zenobi, and how did the idea for that come about?
Yeah, well, that's a funny story, right? I never wanted to start a business, and I definitely didn't want to do it with any business partner. So it says a lot to the credit of my my two co-founders that they got me there, I guess. But the reason for that was I've seen my parents start a family business and joint venture with other companies, pick the wrong partners, have to start from scratch again. So I was like, no, I'm definitely not doing that. It's one of the reasons I moved to the US, was not to take over the family business. I always joke. But with Zenobi, this is early 2016, right? So I started hearing a lot about batteries again in Europe. And my co-founder, Nicholas, he was fighting his neighbor from putting up a wind farm. And he did that by putting up a solar farm and taking the capacity out of the wires, which is quite interesting. But the solar farm was one of the first projects in the UK to have a battery co-located with it. Now, he realized that there was a business there. And when we discussed that, the fundamentals look quite strong, because the UK is an island, but it's a big island. And you can't really export a lot of the problems of the renewable energy transition the way Germany did with the rest of Europe. So strong fundamentals. Secondly, there was an opportunity of a few projects that were struggling. So there was an opportunity to do something immediately concrete, get revenue in. So I think the two of fundamentally being quite a strong business case, and then secondly, tactically having sort of a seed to build around is really what lured me in. And then the third and last element, I would say, was the complementarity and skill sets between the founders, right? So Nicholas came from a merchant and investment banking background, myself coming from trading commodities around physical infrastructure and engineering and batteries. And then James, who joined shortly after, came from consulting in the utility space and understood the regulatory framework very well. So those three things combined were very complementary. And personally, I don't think we could have gotten as far as we did if we didn't have those three different skill sets.
Mm-hmm. And obviously, we've talked there about, how your skills all complemented one another, and it felt like there was a case study and a need for the business. But what were the biggest early challenges in starting a clean tech company?
Well, I think the first thing was getting it funded, right? Because the challenge we had is we were trying to basically invest in battery power plants, small scale distributed battery power plants. And at that time, that was very novel. So nobody wanted to give us any money, right? So venture capital said, oh, it's too asset intensive. Private equity said it's too small. And infrastructure funds said the income streams from the energy markets were too volatile. So we had to go the family, friends, and fools route with our early fundraise. So we raised about £25 million across
Wow.
9 months from people we knew and in the sector. And actually, that turned out to be a blessing in disguise because all these people came with knowledge and contacts. So we had one of the finance directors of Rio Tinto, a former non-exec of Shell, somebody built one of the largest energy brokerage businesses in Europe and sold it to Accenture. We had one of the largest ship owners in the world. We had all these people who have a perspective on the energy market, a perspective on how to grow a business. So I think that allowed us fairly early on to rely on that and build from a very strong base, and also put a lot of governance and lessons in place that we would otherwise have had to learn ourselves the hard way. And if you look at where a lot of companies fail with scaling up, it's silly stuff like cash management, liquidity management, being driving for the best but planning for the worst, that that sort of stuff. We had that from day one, that mindset. So I think again that was very very helpful.
And kind of coming on to, the technology and innovation behind the business and the way things are progressing at the moment. What's the role of AI or automation in your operations today, or how do you see yourself using it in the future?
Well, I think first off, maybe it's worth recapping what does Zenobi do, right? So
Yes.
Zenobi started as a developer, owner, and operator of grid-scale battery power plants. So initially that was 40-foot container connected to the grid and just trade energy or supply basic stability services to keep the lights on a second by second basis. We quite quickly realized that eventually other people were going to build it as well, and you don't really have a competitive advantage, right? Anybody who could get a connection, could buy a battery, install it, could start competing. So we said, well, actually, what are other problems on the grid we can solve that are a lot more complicated, right? So for instance, by going from the distribution network to the transmission network, the number of compliance checks or security checks you have to go through before you can do that safely or allowed to do that goes from 2 tests before commissioning to 493. So that's a lot more complicated, but the rewards are there because you can have a much bigger benefit supporting the sort of superhighways of the electricity network with helping connect offshore wind into the network at a more cost-effective way, or preventing National Grid, the system operator, from having to turn off that said wind because there's a congestion issue, or supporting voltage in a local area. So it's much more technical. Rather than some of the vanilla stuff. So that was one way that I would say technology really, or focus on technology, or what people want to do with that technology, allowed us to strengthen the business case. I'd say the second thing was around how we use data. We quite quickly saw that the system operator was actually solving a puzzle, right? So they won't need to guarantee that the lights stay on now. So they need to be able to react to shocks on the system grid. And some shocks are seasonal, right? People consume more power in the winter than in the summer. But with more renewables and electric cars and all this other stuff, some of these shocks happen on a much shorter time frame. And the problem that they had is they could only buy these services in certain combinations, a bit like you're playing Tetris, right? And you never know which block's going to drop, and then you somehow have to fit it, or it stacks up and you lose. For the system operator, it's a bit similar. They don't know what blocks are coming. Now, if you suddenly insert batteries into that system, it's a bit like being able to pick which block is going to drop next. So we found that we could help them optimize the grid a lot better and get the value from that. So we started using data to monitor the auctions, see which combinations National Grid liked, what had value, and be much smarter in how we went into these auctions and be successful. So that was really our first use of, I would say, data science, but also back when I was in school, we called operations research, which probably would be called machine learning or AI these days, in how do you minimize wastage in a system. So we reverse engineered National Grid's procurement curve and then gave them what had value. And obviously, as a result, we were very successful.
Mm-hmm.
The other bit was then around being nimble and adjusting to the market, right? The other thing that we saw was that these skills we developed were very useful for a new class of large energy users. So if you think of with the big batteries were at the first mile of the grid, at the last mile of the grid, there was also a problem emerging, which is that if you connect lots of buses or trucks to the grid, say a typical bus depot is the equivalent electricity consumption of 1.5 Empire State Buildings. So if that pops up overnight, guess what? The grid's not ready for that. So we found out that by putting batteries in bus depots, smart charging, using data, we could minimize the impact it had on the grid, get these projects on the go faster at a cheaper cost. And also, in some cases, even get paid by the utility rather than penalized. And that sort of, on one side, if we focused purely on the technology, would have never done that. But it was also sort of having the ability to step back and look at the bigger picture and say, well, hold on, this skill set is imminently translatable to this other thing as well. And that allowed us to suddenly tap into a much bigger market, because suddenly we could use our skills to help not just the electricity market, but also the transport market. And then suddenly that allowed our business to grow a lot quicker and get scale a lot quicker, which, as you know, in any sort of startup journey is really quite important. Mm-hmm. And it also allowed us to actually leverage some of our skills even more. So if you looked at, I talked about Nicholas with the finance background.
Yeah.
Financing grid scale battery project was difficult because of the volatile merchant revenue streams, because we had very short contracts. Now in the transport sector, we could get long-term, almost infrastructure-like contracts where we said, look, we'll guarantee these vehicles are always charged over the next 15 years. Now, if you can do that and you have somebody with a strong finance background, you can suddenly leverage that to raise a lot more capital at a lower cost, which then it becomes a bit of a flywheel, right? Because you get more of a cost advantage, which then allows you to convince customers to accelerate the adoption of clean technologies, which then means you need more capital, and the whole thing really starts to roll. And I think that's how we've really been so successful over the last few years in terms of growing from 9 buses in Guildford in 2019 to now supporting 3,700 electric buses and trucks across 9 countries. Mm-hmm. It's really been around understanding the technical problem, but then being able to translate that in a way that the banks understand and can provide you with cheap capital.
Absolutely. And what would you say are some of the biggest tech hurdles you're still trying to solve then?
How do you do software innovation quicker, right? Because I think that's one thing. How do you get the sort of the tendency of people to turn everything into a big, massive project that says, oh, yeah, that's going to take 18 months to complete. How do you chop that down into little things that you can do in sort of 6-week sprints? Mm-hmm. I'd say, be that software or hardware, that's one of the big challenges. Making sure the organization stays sufficiently flat so that everyone has contact with the customer, and that people remember that the reason you're putting processes and automation in place is to get a better customer experience, not goals in and of themselves, right? I'd say those are 2 big challenges. And then thirdly, it's how do we leverage this data we've got even more, right? I mean, we see it now, we've done 140 projects so far. We are doing, I think, 60 projects at any given point in time now that we've got in construction, so we're still growing very fast. how do you make sure that the learnings you have on one immediately get spread across the organization, so that, for example, the one thing you learn on that project in New Zealand, that knowledge doesn't get lost, but makes it to the guy in Massachusetts, in the US, and they can apply that on the project that they're working on. So it's more about, I'd say, not necessarily about the innovation, but about the distribution of that innovation across the organization. I'd say that's the biggest challenge.
And what potential do you see in second life battery storage and the circular battery economy?
A lot, right? I mean, we've got what, 54 or 56 projects live now, and that goes from powering things like the crown on a film set to powering tower cranes at Sizewell C's construction site, and avoiding the use of diesel, making construction sites less noisy, and I cannot stress this enough, saving our customers massive amounts of money in the process, right? I mean, if you look at some of these large construction projects going over budget, if we had a larger adoption of some of the solutions we were providing to them, we could save them hundreds of millions, which eventually will be funded by the taxpayer. So sometimes it's a bit surprising why you don't see more adoption. But I think that taking a step away from maybe the tactical is thinking strategically, right? We've spent a lot of money and resource taking the minerals out of the ground, shipping them to China or Korea, right? That's where most of the supply chain is. Turning that into a valuable product, it again goes on a vehicle, runs around for a while, and it comes off and it still has a life. I mean, it's almost a crime to recycle these things, because you're turning it back into its component parts, and you're destroying the value of all the labor and energy that went into turning it into a pack. So we should really monetize the value while it's in country, and also think from a geopolitical and a sustainability perspective, keeping these things in the place where they are, right? If you've got buses in the UK, the battery comes off, using that battery in the UK for as long as possible. Yeah, it just ticks a lot of boxes. So I would expect everywhere you see a diesel generator right now, you'll slowly start seeing second life batteries popping up over the next few years.
And do you think that's the biggest opportunity for growth in clean energy, or what else do you see being a big opportunity?
Where to start, right? I mean, obviously, if you start top down, obviously there's a lot of opportunities in batteries on the grid, and there's a lot of opportunities in electric transport. But if you really go one level up, I think the first thing is digitisation, right? I mean, if you speak to most utilities, they have no idea what's happening on their network. And then they might be slightly offended by me saying that, but if you really challenge them on that, I think they'll admit that it's true. So they don't know how much energy is going through a particular wire. They don't know how much is going through a particular substation. So digitization of that with dynamic line rating and monitoring, I think, can help us unlock a lot of value in existing infrastructure. If you then still see bottlenecks, then the next step is using batteries and renewables rather than lots of the other technologies on the fossil fuel side. Because I mean, we already know today solar, battery, and wind combined is cheaper than coal. It's cheaper than nuclear, and it's more stable than nuclear as well, and more reliable than these technologies too. So that's, I'd say, the second thing. And then the third bit is, I'd say, in clean tech, anywhere you've got this sort of confluence of digitization and wastage, that's where you need to look, right? I mean, I think the reason we're, again, been able to grow so quickly is we focused on saying, look, people don't want to pay a green premium. People want green discounts, right? If you want mass adoption, it shouldn't only be more convenient, it should be cheaper. And that might be the cynical approach to climate change, but it is the easy path, right? And in the meanwhile, we buy time and we learn so that we can electrify the next bit. And I'll give you an example of that. We've done projects with customers where initially we thought, oh, we'll need this much grid capacity and it'll cost this much. And the customer says, oh, we'll never be able to fully electrify this depot. In the end, we said, well, let's start with these 10 buses, because we know on these routes, you will actually save money doing this. And it worked. So then I said, oh, we'll order another 19, so 29. Then eventually we went to add another 130, so slightly bigger step. And now we're adding another 130. And guess what? That includes some of these early routes that they said could never be electrified. And the reason we're able to do that now isn't because of massive advances in technology. It's about operational information. We started getting data back from the vehicles that we could use to train the drivers. And it worked out we could train the drivers in such a way that they need 40% less electricity. Obviously, if you need less electricity, it's cheaper to run. So the advantage against diesel increases, but also you need to put less copper in the ground and infrastructure and less charges. So you need to make a smaller investment. And then suddenly customer realize that actually they could do this with very minimal government support, or potentially get to the point where they don't need government support. And I think that's the value of taking small incremental steps rather than analyzing yourself to death and trying to do a monster project.
Yeah. And what advice would you give to someone who's looking to enter energy tech today?
Like I said, it's look at those opportunities where there's a lack of data. There's if you go back to the core fundamentals, there's an opportunity for massive savings, and focus on that. Don't try and go after the last most expensive kilowatt hour. Go more after the obvious stuff. And the other bit that I would say is try and do the energy sector is also very heavily regulated, right? So try and do it in a way that what you can do works in the regulatory framework today, rather than saying, oh, if the rules changed, we could do this, because unfortunately the rules change very, very slowly.
Absolutely. And we come on to the trending in tech round now. With the UK accelerating its transition to net zero, fleet electrification, particularly for buses and trucks, is gaining momentum. At the same time, there's also growing interest in second life battery applications, which can extend the value of EV batteries and support a more circular economy, which we've kind of touched on today anyway. But given your work in this space, could you share your perspective on the key challenges and opportunities in scaling electric fleet infrastructure, and how can second life battery solutions play a role in building that more sustainable and resilient energy ecosystem?
Yeah, I might say something slightly contrarian. The first most thing that we need the most is actually we don't necessarily need lots more subsidies to go electric. We don't need necessarily lots of specific policy making to mandate electrification, or people promising, oh, we'll do it by 2038 instead of 2040 or 2032, because that sort of stuff, it's so far away, it doesn't really help. And the problem with subsidies is people then say, well, why would I do something today if I can get free money tomorrow? So those are our two big challenges. The biggest challenge in electrification of transport is we should try and push things to the mode of transport that is already the cleanest, right? If you look at that for packages, it's the coastal barges, it's the river barges or rail rather than truck. And the nice thing is, if you get all those trucks off the road, then suddenly the buses in downtown London will move quicker because they're not stuck in bloody traffic jams all the time. So, and that's actually quite important, right? Because if you look at it, Transport for London did a study that was presented in, I think, the House of Lords, where, and they did this like 10 years ago, I think, where they showed that every mile per hour that road speed declines costs them 250 million a year. And road speeds have dropped more than 10 miles per hour in the last decade. So that's 2.5 billion, right? TfL could be a money-making enterprise if we tackled congestion. Now, if you start that, you can invest loads of things, right? More buses, more frequent buses, nighttime buses. Oh, and by the way, we could make them electric as well, because that's the cheapest way to run a system anyway. So I think starting at the basis and at the fundamentals of how do you run a good transport system is the most critical thing, rather than doing anything particularly on the clean tech side. Now, obviously, once you are, if you, again, like I said earlier, policy change is difficult. What can we do in the margins today? Well, that's around looking at these things as integrally connected to the energy grid, and sweating these assets as much as possible. So what does that mean? I mean, things like what First Group and Zenobia are doing, which is opening up our depots for other people to charge, right? Because we've got great infrastructure, we've got better utilization of our assets than any public charge point operator in the UK, right? We're at plus 25%, but that's all at night. So technically, if we open it up during the day, maybe we can get to 50. That's quite exciting. And you wouldn't have to charge 70 cents there per kilowatt hour either, which is really exciting for people who don't have off-street parking at their homes. And that can really then start to snowball, right? Because you've already invested in the buses. You can now make that infrastructure available for much cheaper for trucks, which then makes it more easy to go electric on the trucks, which means they do more miles than the buses. So you get even more second life batteries available to then do all those reinforcements at the grid without having to pull new wires and substations all across the country and unlock the value we've got in our existing infrastructure. So I think that's really exciting because you can get this real true positive compounding or snowballing effect where every incremental change costs less and less. And that's sort of what makes me hopeful that despite of ongoing regulatory uncertainty around franchising nationalization, or if you look at all the stuff coming out of the White House and in Europe, increased focus on defense, that actually there's only a few levers and a few projects you got to get right in order to really start that positive snowballing and still sort of meet our climate objectives and saving the taxpayer money over the next 10 years.
Absolutely. Lots of food for thought there, I think. But we come on to the final part of the podcast, which is the quick fire this or that round. So we find out your favorite picks. So Steven, if you had to choose, are you an iPhone or a Samsung person?
Well, I'm sitting here with a Samsung phone. I don't like walled gardens, so there we go.
And Spotify or Apple?
Well, same answer, right? Spotify again.
And Netflix or cinema?
I don't have time for either, I'm afraid.
And laptops or tablets?
Laptops, because I can't be bothered to relearn all the Excel shortcuts.
And ChatGPT or virtual reality?
I'd say the former, right? Again, I don't have time to look at a television, so I don't imagine much time. I guess it depends on people's skill set. Right? I've got a friend who's a surgeon, and he says the augmented reality stuff is really helping to make a big impact on patient life. I think with ChatGPT, it's good to get to sort of the average answer or quickly whiz up on a particular wisen up on a particular topic. But it doesn't beat doing the homework or having the experience to then judge that answer.
And video calls or voice notes?
I don't even, as people will know, my voicemail messages, please don't leave me a voicemail, send me a text. So.
And finally, if you could bring back one piece of tech that's either now evolved or it no longer exists, what would it be and why?
One topic is if you look at it right now, right, is electric vehicles. They have an electrical motor inside them, and there's one thing that again they put on largely on the transmission grid now is synchronous condensers to deal with reactive power and the consequence of putting lots of digital technologies on the grid. So one of the things I sort of wonder about is that if you've got an electric motor in a bus, isn't there a way to suddenly or in a car, make all those things, do that work for us so we can avoid having to pay twice? But a slightly niche answer to that question, I'm afraid.
No, and it's still a great fact to know. But thank you so much for your time today, Steven. It's been great talking to you about this topic. I'm sure there's lots more we could digest, but we really appreciate you joining us.
No, thanks for the invite.
Thank you.